Okay, in next few videos we're gonna to go through the first AS paper from new specification, okay, for Edexcel. Question 1. Find the integration of 2/3 x cubed minus 6 root x plus 1 with respect to x. Okay, giving your answer in its simplest form. Okay, I wrote down the question once more here just to make it more visible. So integration of 2/3 of x cubed minus 6 root x plus 1 with respect to x. First of all, we need to write down the equation in such a form that we should be able to integrate that. So 2/3 of x cubed minus 6 x to the power of half add 1. Okay. So we know that integration of 2/3 of x cubed is equals to, so let's write down the full solution for this one. 2/3 over 3 plus 1, which is 4, x to the power of 3 plus 1 is 4, minus 6 over half plus 1 is 3 over 2, x to the power of half plus 1 is 3 over 2, add integration of 1 is x plus constant c, which is equals to 2/3 over 4 over 1, or 2/3 times by 1 over 4, which is 2 over 12. X to the power of 4 minus 6 over 3 over 2, which is 4, x to the power of 3 over 2, add x, add c, which could be simplified to 1 over 6 x to the power of 4 minus 4 x to the power of 3 over 2, add x, add c. Okay, so let's move on to question 2 now. It says show that x squared minus 8x plus 17 is greater than 0 for all real values of x. X squared minus 8x add 17 is greater than 0. There are several methods to show x squared minus 8x plus 17 is greater than 0. The most common method is completing a square. Another method could be using discriminant and also showing there is no root, no real root for this equation. And another method obviously would be using integration to differentiation to find the minimum coordinate. Okay, so let's use completing a square for this. X squared minus 8x plus 17, so we could write down x minus 4 all squared minus 4 squared plus 17, which becomes x minus 4 squared add 1. So we know that x minus 4 squared is always greater or equal to 0. X minus 4 squared is always greater or equal to 0. Why? The minimum value which x minus 4 squared can take is 0 when x is equal to 4. For example, 4 minus 4 is 0, 0 squared is 0, so greater than 0. Any other number for x would make x minus 4 squared always positive, greater than 0. Okay, so when you add 1, it would be x minus 4 all squared add 1 is obviously greater than 0. Okay. The next part of the question, part 2. So this one was part 1. Part 2 of the question, if I add 3 to a number and square the sum, the result is greater than the square of the original number. State giving a reason if the above statement is always true, sometimes true, or never true. Okay. So for this question, it is sometimes true. Okay, let's give an example. For example, 2 plus 3 squared. Let's see if it's greater than 2 squared. 2 plus 3 is 5. 5 squared is 25, which is greater than 4. It's true. Okay, so let's see, for example, for minus 2. Minus 2 plus 3 squared is less than minus 2 squared. 1 is less than 4. Okay, so therefore, if I add 3 to a number and square the sum, the result is greater than the square of original number. So we can see in some cases it is true, but some other cases it's not. So therefore, it's sometimes true. Okay. However, we could solve this one algebraically as well. Okay. So let's write down x plus 3 squared, okay, is greater than x squared. Let's expand this one. X squared plus 6x plus 9 is greater than x squared, which means 6x plus 9 is greater than 0. 6x is greater than minus 9, and x is greater than minus 9 over 6, or x greater than minus 3 over 2. So therefore, it is true for all the values of x greater than minus 3 over 2. So it works for x greater than minus 3 over 2. Let's move on to question 3 now. Given that the point A has position vector 4i minus 5j, and the point B has position vector of minus 5i minus 2j, find the vector AB. AB is a vector which starts from, so let's write down the formula first. AB is equals to OB minus OA. So let's write down OB and OA. So OA is equals to minus 5 minus, let's write it down as a column vector, minus 2. And OB is equals to 4 and minus 5. Therefore, AB is equals to 4 minus 5 minus 5 minus 2, which is equals to 4 minus minus 5, which is 9, minus 5 minus minus 2, which is minus 5 plus 2, which is minus 3. So therefore, AB could be written as a 9I minus 3J. Okay, so we've got the vector AB now, and now we're gonna to work out the length of AB or modulus of AB. Length of AB is equal to, using the Pythagoras theorem, 9 squared, square root of 9 squared plus minus 3 squared, which is 81 plus 9, which is square root of 90. Square root of 90 could be written as square root of 9 times by square root of 10, which is 3 square root of 10. Okay. Now let's move on to question 4. The line L1 has the equation of 4y minus 3x. So let's write down the equation for L1. 4y minus 3x equals to 10. The line L2 passes through the point 5 minus 1 and minus 1 and 8. So I just write it here, 5 minus 1 and minus 1 and 8. Determine, giving full reason for your answer, whether line L1 and L2 are parallel, perpendicular, or neither. So, to identify whether they are parallel, or perpendicular, we have to work out gradient of the both of the equations, both of the lines. Okay, so let's, for line L1, let's work out the gradient. It would be 4y is equal to 3x plus 10. Then divide both sides by 4. You get y equals to 3/4 x plus 10 over 4. And therefore y is equals to 3/4 x plus 5 over 2. We need to also write down the gradient for L2. So gradient of L1, let's call it M1, which is 3/4. Okay, gradient of L2, for L2, let's write down M2 is equals to y2 minus y1, 8 minus minus 1, over minus 1 minus 5, which is 9 over minus 6, which is minus 3 over 2. Therefore, M2 is equal to minus 3 over 2. Now, let's look at the conditions for parallel and perpendicular. L1 is parallel to L2 if M1 is equals to M2. So M1 is equal to 3/4, which is not clearly equal to minus 3 over 2. Therefore, they are not parallel. Okay. Next one, L1 is perpendicular to L2 if M1 times by M2 is equals to minus 1, or M1 is negative reciprocal of M2, which is the same thing actually, or M1 is equals to minus 1 over M2. Let's see if it's the case. 3/4 times by minus 3 over 2 is equals to minus 9 over 8, which is not equals to minus 1. So therefore, they are not perpendicular as well. Okay, so not perpendicular. So the lines are not parallel as they do not have the same gradient. And the lines are not perpendicular since m1 times by m2 is not equals to minus 1. Okay, so in next video we will go through the next 4 questions.